We shall now be diving straight in, and will use some code already written. Detailed explanation of the code will also be provided. There is an AutoCAD drawing, with some lines, polylines and circles in it. Our mission is to tell user, how many lines, polylines and circles are present in the entities selected by the user. Let's now have a look at the drawing. We shall also learn how to customize rollover tooltips that are displayed when we hover mouse over any entity. AutoCAD version 2022 is used here, but this will be similar for any recent version of AutoCAD.
Whenever mouse is hovered over any AutoCAD entity, a tooltip like this displayed. Some properties of entities, like entity type, layer, color are shown by default. We have changed the color of this polyline to red, and that is reflected in the rollover tooltip as well. The properties displayed in this tooltip can be customized. Go to the Manage tab, and then click on User Interface. Look for the item rollover tooltip in the left pane. You can change the properties that are displayed in tooltip for all the entities. Click on the Reset Overrides button at the bottom, and then click Apply and OK. As you can see, the change is reflected in the tooltip. Line type is not shown. Now, let's make as it was previously, and add the line type again. Some properties of some specific type of entities can also be added to the tooltip. We are adding X, Y and Z coordinates to the center of the circle. Now, whenever mouse is hovered over a circle, coordinates of center can be easily seen in the tooltip. Likewise, start and end point coordinates, length and angle of a line can also be added. You can add any property available in this dialog, which you want to visually access very easily.
We just saw one AutoCAD drawing, with some lines, polylines and circles. You can create another drawing like this. Although, the part of customization of rollover tooltip is not necessary for this tutorial, this is provided as a bonus. AutoLISP is a Lisp-based scripting language for AutoCAD. For being proficient in AutoLISP, thorough knowledge of AutoCAD is required. Let's now see how to get the code used in this video. The most easy way is to go the code file on GitHub and copy-paste it in Visual Studio Code. URL for code file is in the description of this video. Creating a new AutoLISP file in VS Code. Go to the GitHub file URL and copy the contents. Paste in VS Code. Now, a slightly more difficult way of getting the code on your local machine. Git command line tool needs to be installed on your system. Go to gitscm.com, download the installer, and follow the instructions for installation. After Git is properly installed and working, open the terminal window and fire the command for cloning one branch of the repository. Command for cloning is given in the description of this video. This procedure is slightly more difficult, and a separate video will be uploaded, explaining this more details. Git clone single branch. This tells Git that we want to clone a single branch of a repository on GitHub. We are then telling Git name of the branch we want to clone. Hands-on 1 is the branch we want clone. And this is the Git URL. Git URL is not the same you see in the address bar of the browser. Git URL can be found at the location shown here. Copy this Git URL and paste in the command line. There are just 2 branches currently in this repository, and our code is located in the branch named hands-on 1. Firing this command will clone one branch in the current folder. The code in the branch is now present in the subfolder named AutoLISP YouTube. Navigate to that folder, and then open the folder in Visual Studio Code.
Let's now start analyzing the code. Full source code can be found on GitHub. Follow the instructions given in the description. What you are seeing is a function with an entire function body folded. Notice the CN: before the function name. This denotes that the function can be run just like any other AutoCAD command, and enclosing the function in round brackets is not required. What you are seeing is the function body expanded. Code blocks inside the function are still collapsed. Variables are initialized here. Cell set is for selection set, tot lines, tot polylines, and tot circles, for holding total numbers of lines, polylines and circles, selected by user. This code first prints a message asking user for selecting entities. It then invokes ss_get command, and assigns the selection to the variable cell set. This code, in the if block, runs only if user selects some entities. If user doesn't select anything, variable cell set remains nil, and the if block is not executed. The else block is executed. A blank prints is provided here, so that the functions doesn't print anything after all the code is executed. If block is now expanded. Inside the if block, all the statements inside the prog_n block are executed, if the condition is true. Note that prog_n is used for gluing multiple statements together. If the condition is false, that is, the variable cell set is nil, then the print command is executed. And the message, no features selected, is displayed. This is the prog_n block expanded. This block is executed if the variable cell set is not nil, that is, user selects some entities. First statement in the prog_n finds length of the selection set using ss_length function and sets it to the variable movement. Value of I is initialized to 0 here. This acts as a counter in the while loop that follows. This is the while loop. Code inside this loop is executed till the value of I is less than num_ent, that is, number of entities selected. I is incremented inside this loop by 1 in every iteration. This is what happens inside the while block. At the top, ss_name function is used for getting ith entity in the selection set. And at the bottom, I is incremented by 1. So, the variable ent will be holding values of first, second, third entity in the selection set in each iteration of the while loop. The conditional block, which is collapsed currently, checks type of the entity, like line, polyline or circle, and increments respective counters. This is the conditional block. Inside this, counters are incremented by 1, depending upon the entity type. This is the conditional block expanded. First line, find out the type of the entity. This line deserves more explanation. and will be discussed in the upcoming video. Second line in the conditional block increments the counter for the line type by 1. There are many similar conditional blocks that find out the entity type and increment the respective counter. This block checks if the entity in the selection set is circle, and if it is a circle, it increments the counter for circle by 1. And here, outside the conditional block, counter I is increased by 1. So that, in the next iteration of the while loop, next entity in the selection set will be processed. While loop goes through the entire selection set and scans all the entities one by one. And then depending on entity type, increments the counter for that entity type. These are the lines outside the while loop. They print count of all entity types that are handled in the conditional statement. I2A statement is used here for conversion of integer counters to strings. And this is the else part of the if statement. If selection set is nil, that is, if user doesn't select any entities, it prints this message.
Now, let's see the code in action. Remember, Visual Studio Code extension for AutoLISP is needed to be installed. Make sure AutoCAD is running. This AutoCAD file contains some lines, polylines, circles and some other entities. Go to the Run menu of Visual Studio Code and select Run without debugging. The part of debugging will be covered in subsequent videos. Select the running AutoCAD process. Now, a function named FeatureSelect should be loaded in AutoCAD. Let's run the function. As expected, it's prompting for selecting the features. And as soon as user completes the selection, it displays counts of lines, polylines and circles.